Welcome to my channel Beyond Formula, and today we're going to be deriving the sum and difference trig identities for cosine and sine. So the way we're going to first start is to derive cosine alpha minus beta, because this is going to allow us to get the other ones. So our first step is using the unit circle. We're going to draw a line here, this point being P, and we're going to draw another line. It's going to be Q. And we can connect these two to make a triangle, and this will be point O. So what we're first going to do is label the angles. This angle that goes from the 0 degree to Q is going to be called alpha, and this smaller angle is going to be beta. So this makes the angle in between both of them alpha minus beta. So we're going to try to find the length of PQ. And one way we can do that is using the law of cosines, because as you can see, the PQO is a triangle. So PQ squared is equal to 1 plus 1 minus 2 cosine alpha minus beta. These two sides are 1 because it's a unit circle and all the radiuses are 1. And we can simplify this to 2 minus 2 cosine alpha minus beta. And another way we can also do this is using the distance formula, which is another application of the Pythagorean theorem. Any point on the unit circle can be written using sine and cosine for their x and y coordinates. So that's how we're going to be finding the distance. So this is going to be PQ squared equal to cosine alpha minus cosine alpha minus cosine beta whole squared plus sine alpha minus sine beta whole squared. And now we can see that the left-hand sides of both these equations are equal, so we can just make the right-hand side equal to each other as well. So 2 minus 2 cosine alpha minus beta is equal to cosine alpha minus cosine beta whole squared plus sine alpha minus sine beta whole squared. Now we're going to simplify this. The left side is going to remain the same. We're just going to simplify the right. So it's going to be, this is basically just a minus b whole squared. And we're just going to write that out. So cosine alpha squared minus 2 cosine alpha cosine beta plus, I'm just going to have to continue over here, plus cosine beta squared. And now for the second part, sine squared alpha minus 2 sine alpha sine beta plus sine beta squared. And now, due to our Pythagorean identity, we can cancel cosine squared alpha and sine squared alpha, and that equals 1, and cosine squared beta and sine squared beta to 1. So now both sides, the left-hand side is still 2 minus 2 cosine alpha minus beta. Now the right hand is 1 plus 1, so 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Now you can cancel the 2's. We can also factor out the negative 2 for both. So this just gives us cosine alpha minus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And that is our first identity. This should be plus because we factor out -2. Yeah. So now what we're going to do is find cosine alpha plus beta. A simple way of doing this is just we can switch around the beta part and just write this as cosine alpha minus negative beta, and the equation still works. So it'll just be cosine alpha cosine negative beta plus sine alpha sine negative beta. And we can just pull out the negative signs for both, but because cosine's an even function, the negative sign won't come up, but sine's odd, so the negative sign will come up. And this will just be, so the left hand side, is cosine alpha plus beta. And now the left hand side is just cosine alpha cosine beta minus sine alpha sine beta. And that's our second identity. Now what we're going to do is derive sine alpha plus beta. So a pretty nice way of doing this is starting with sine alpha plus beta. And now we can use our reduction formula to change this into cosine pi over 2, or 90 degrees, minus alpha plus beta. So one of the reduction formula is basically cosine 90 degrees minus alpha is just equal to sine alpha. And that's what I did in this case, except alpha is alpha plus beta. So and then we can further simplify this to cosine pi over 2 minus alpha minus beta. And I'm just going to group these two together. Now what we're going to do is just apply it back with this formula because it's still in the form of alpha minus beta. So that'll be cosine pi over 2 minus alpha cosine beta plus sine pi over 2 minus alpha sine beta. And now what we can do is use the reduction formula again. So this is just going to give us, this is just going to switch the function. So it'll be sine alpha cosine beta plus cosine alpha sine beta. And that's our third identity. And now for the final one, what we can do is just derive it from the sine alpha plus beta. So we can write this as sine alpha plus negative beta, which is basically alpha minus beta. But we just want to make it work out with this formula. So this will be equal to sine alpha cosine negative beta plus cosine alpha sine negative beta. And now we're going to use another one of our formulas, and this is just going to simplify the negative parts and bring them out. And the only thing that's going to happen is just because sine's odd, the negative sign will show up in front. So this is just sine alpha cosine beta minus cosine alpha sine beta. And that's our final identity. So these identities are like really important. You might have to memorize them for some of your tests or assignments, but I recommend always knowing how to derive it because in case you forget it, you can just derive it on the spot. And remember these because they'll be really useful in your classes. So if you guys enjoyed this video, make sure to like and subscribe to my channel Beyond Formula. And thank you for watching. Bye.